Welcome back to New Record Day. My name is Ron, and in this week's episode of Tuesday Tech Talks, Norman from AV RoomService walks us through a crash course of all things related to noise and how it relates to our hi-fi systems. Enjoy the show. Comments down below.
Welcome to another segment of Tuesday Tech Talks. I'm Norman Varney with AV RoomService, specializing in acoustics. Today we're going to do a crash course on noise control, because before we can talk about sound quality, we have to have noise under control. So what is noise? Noise would be anything that is not a part of the original signal. So it could be a noise from outside of the building, like a car horn or an airplane or rain on the roof. Or it could be noise from inside the building, but outside of the listening room, like people talking in an adjacent room, or kids running around the house and footfalls. It could even be plumbing in the walls. Or it could also be noises from inside the room that you're listening from. And that could be equipment fan noise. It could be HVAC, it could be an electrical hum in the background. So there are two types of noises that are not a part of the original signal. So we're talking about airborne noise. Airborne meaning the direct sound through the airwaves from the loudspeaker, or like my voice, this is airborne sound. Or it could be structure-borne sound, and that would be rattles and buzzes and resonances, or it could be, like we've discussed, impacts. It could be a steady or variable continuous vibration, or it could be some impact that is forced upon the structure. Need to talk about ambient noise. Ambient noise would be all of that noise, all of the encompassing noise. And then there is the noise floor. And the noise floor would be the lowest level of noise from a sound pressure level point of view that can be obtained. In other words, this is the bottom, nothing gets lower than this level. That's the noise floor. So what is noise control? Well, by definition, noise control is the technology of obtaining the acceptable noise environment in line with the economical and functional considerations. So then you're going to ask yourself, well, what is acceptable? And that's going to depend on the situation. In our playback, your playback scenario, that's going to be personal, and it's going to be driven by these other considerations. What is acceptable? So in a recording studio, you want an ambient level of, and that means with the HVAC going on, you want an ambient level of about an RC20. That's or better. That's pretty quiet, and that's going to take a lot to obtain. For example, as far as reference, that's a good 10 dB quieter than your typical residence background noise. There are other considerations. For example, myself, a noise and vibration specialist, there are other considerations and other scenarios that you have to look at it. There can be regulations, code, and so forth that has to be looked at as far as privacy in dwellings and in office spaces and such. So the noise and vibration industry is well established. There are all kinds of standards for testing materials and systems, and in order to comply with rules and regulations, and in order for a building to pass code, for example. So what is acceptable is going to depend on the different scenario. How much reduction is required? Again, we've kind of discussed that a little bit. Ideally, we want an ambient noise floor that is that is low enough that we are going to be able to hear all of the music's dynamic range. And we want to be able to hear all of the low-level details, all the low-level resolution in the music material that we're listening to, so that it isn't being masked by noise. Noise can also be a real distraction, and it can draw you out of the experience. Another thing to consider is that noise is a two-way street. So if noise can get into your listening environment, then it can also get out. We have a surround sound acoustics lab down in the basement. So it's a dedicated space. It's a room within a room. And I can play Master and Commander, the movie Master and Commander, with the cannons and all, and my wife can sleep in the master bedroom, which is directly above. Something to also consider is, when you're talking about noise control, is that the quieter it gets, the more little tiny noises become more of a big deal. So it's kind of a double-edged sword in a way. For example, I've spent a lot of time in an anechoic chamber doing R&D and testing and so forth, and when you're in there for a time and you get acclimated, you can hear not only your heart beating, but you can hear your blood flowing, and you can even hear your eyelids when you blink. So there is a point where it becomes too quiet, and any little noise becomes a real distraction. So from a professional point of view, just for your information, we'll talk about how you figure it all out. And there's three steps to that. The first step is to evaluate the situation, either from either the existing or the estimated, if it hasn't been built yet, for example, conditions. And so with the existing conditions, you can bring in some test measurement equipment, and the process, you're going to collect statistically significant data with professional equipment. So and there are tests, there are standards that you abide by. So you have to select the right equipment for the particular test that you're doing. It has to be calibrated. The process has to be followed so that your data is consistent and repeatable, and so that it complies with others and or building materials and so forth, so that it makes sense if you are doing modeling or so forth. There are empirical methods that you can apply if you're just estimating for a particular scenario, and you know the construction materials and methods and so forth. So if it's on site, it's a lot of sleuthing. Otherwise, it's a lot of experience and applying what you know. So the second step is to determine what noise level is acceptable, and hopefully that's already been established. So in our case, it's determined by you personally. What are you willing to live with? What are you willing to tolerate? And how does it apply to your conditions, your budget, the physical and budgetary constraints that you have to deal with? And maybe you're in an apartment and it's just temporary, it's not even yours, and so that can limit what you can actually apply as far as noise control. And then the third step is the difference between steps 1 and 2. So this is what you have, or what your estimated is noise conditions are, versus this is what your noise criteria is. This is what your goal is. And so what's the difference between those two? That will tell you the noise reduction that has to be applied in order to obtain the goal. There's 3 areas for controlling noise: the source, the pathway, and the receiver, or the listener, you. So at the source, there's several things that you can do to control it. You can reduce whatever that noise source is. Let's say it's an appliance or something like that, or maybe it's your kid's stereo. You can tell them to turn it down. You can enclose that noise source with something that helps to block and absorb the sound energy. You could install isolators under that source. And for example, in Ron's situation, he had a fireplace that was making, structural noises when he was playing his system. And can you imagine how much that would have been difficult and costly to to resolve at the source? So instead, a real easy and simple fix was to put our EVPs, what we manufacture, are equipment vibration protectors under the speakers. So now the vibrations didn't transfer from the speakers into the structure and then rattle that fireplace. You can also isolate the structure. So floating floors, resilient wall systems, suspended ceilings, all those things. And they do contribute to sound quality as well, but mainly because of the fact that now those are not vibrating, they're not resonating, they're not rattling and buzzing. So then the second thing is along the pathway. So you could put the noise source as far away as possible. You can, along the pathway, you could set up blocks that block the sound wave, absorbent materials that absorb the energy and transfer it to heat, or you can break the sound path by, for example, the EVPs, the isolation vibration protectors. And then lastly, there's the receiver or the listener. There's not a whole lot you can do in this situation. You can improve your space with some absorption material, and we will talk about that regarding sound quality in future videos anyway. If it were a sound privacy issue, you could put white noise to mask it, or some other kinds of noise, or you could wear noise canceling headphones or earplugs or whatever. So there's not a whole lot that can be done in on the receiver part. So at the source, along the pathway, or the receiver. Those are the two ways, or the three ways. I hope that you've learned something about noise control from this video that you can apply to your situation and your system, and to see you in future Tuesday Tech Talks. Thank you.